Good morning. My name is Kavish Pran from 5th standard TIE section. Today my Technosium topic is nets of 3D shape. What is 3D shape? The another name for 3D shape is prisms. It is a 3-dimensional shape. It is a solid object that has length, height and width. The founder of nets of 3D shape is Albrecht Dürer and the 3D geometry shape is Euclid of Alexandria. The process to which a 3D shape forms is known as nets of 3D shape. This is the process. Difference between 2D and 3D shape. 2D shape, it will be flat, it has only sides, it has length and width, it cannot hold anything. Example for 2D shape is square, rectangle. 3D shape, it will not be flat, it has length, height and width. Example for 3D shape is cone, cylinder and triangular prism. Faces, edges and vertices. Faces. Faces is the flat surface of a 3D object. Edges is the line segment through which two faces meets. Vertices is just like the corner or an edges of the 3D shape.
My name is Jitashri. Today I am going to explain you about handling data. Do you know about handling data? The meaning of handling data is collection of information. It has many types such as line graph, bar graphs, pictograph and many. Now I will show you some of them. Now it's bar graph. Bar graph is a chart or graph that represents in a categorical data is called bar graph. It is in a rectangular bar. The picture of bar graph is this. The class 7 has 25 students in class 8 has 35 students. The class 9 has 20 students. It is showing that the class 7 has how much people, class 8 has how much people and class 9. Now I will explain you about pie chart. A pie chart is in a circular graph. It is divided into many slices. It is it is a type of a bar handling data. Now I will show you the picture of handling data. In a class, people who like football is quarter people like football and basketball as same as football. Badminton same as football and basketball and badminton is same. The hockey is half than the basketball, football and badminton same as cricket. Now I will explain you about line graph. A line graph is a tool used in a statistic to analyze the trend of data that changes over a specified interval of time in a coordinate plane. Now I will show you the picture of line graph. In a day, the temperature on 6 a.m. is 35 degrees Celsius and in 10 a.m. is 45 degrees Celsius. In 2 p.m. the degree is lesser than the 6 p.m. and 10 p.m. as 30. Thank you.
My name is J. Rishika and I am studying in 8th standard I section.
And I am V. Lakshita from 8th standard J section.
Today we have an interesting topic which explains that maths is all around us. So before proceeding, many are thinking that only science is all around us. Actually, the fact is,
math is a basic of science to be all around us. Let's take an example. If you are walking, it is a science. So we use mathematics in science, like the angle where you walk or how much seconds it takes you to walk and etc.
So let's see an example where maths is applied in nature. So one male honeybee needs only one parent, that is female parent. But one female honeybee needs two parents, that is one male and one female parent. We'll see the family tree of one male honeybee.
So this is a male honeybee and this orange one is a female honeybee. So male honeybee needs a parent female honeybee and female honeybee needs a male and a female parent. So this male honeybee needs a female parent and this female honeybee needs a male and a female parent. So it goes on this way.
So if we count how many honeybees are there in each row, we'll get 1, 2, 3, 5 and 8. So this 1, 1, 2, 3, 5, 8 and so on is called as Fibonacci series. we'll see the proper definition of Fibonacci series. Fibonacci series is a sequence of numbers in which a new number is produced by the sum of the previous last two numbers. So, first number is 0 and the next number will be 1. When we add 0 and 1, we will get next 1. Then, if we take the last two numbers, that is 1 plus 1, we will get 2. Then 1 plus 2, 3. So this sequence will be going on and this sequence is called as Fibonacci series. Even this Fibonacci series is there in your hand. When you take your hand and if you measure your middle finger, we have 4 joints. If you measure each and every joint, first joint will be 2 cm, second joint will be 3 cm, third joint will be 5 cm and the last fourth joint will be 8 cm. This 2, 3, 5, 8 is called as Fibonacci series. Now we will see where it is applied in plants.
Assume this as a sunlight. So you can see that the bottom leaf doesn't get sunlight because it is hidden by the first leaf. So it cannot do photosynthesis and gets dried up. So we use Fibonacci series here to arrange the leaves in an order where all leaves gets in sunlight.
Now we have to arrange all these leaves in a specific angle where all the leaves will get proper sunlight. If we try 90 degree, then also it is not possible because fifth leaf will be overlapping over the first leaf, and if we try any other angle also it is not possible. To find the proper angle, we use Fibonacci series.
My name is K.S. Ridhuvarshini. I am from 8th I section and I am here to explain about polynomial roller coaster. First, what is polynomial? Polynomial is referred as one or more than one term. And roller coaster. What is a roller coaster? Roller coaster is referred as a machine that works based on gravity and innovation. What is the link between these is the tracks. The tracks are constructed using polynomial equation. Here is an example of it. Here an equation is chosen based on this form. Here y is equal to the height, x is equal to the distance and a, b, c are coefficients. The coefficients cannot be chosen on our own because the tracks may not be safe or unique. It is chosen based on the algebra computer classes where the coefficients are found and the equation is being solved, where we get length, height and distance. When we get these, we can create a 3D model of it. After that, the engineers build the tracks using the 3D model and it's checked whether it's safer or unique. We get vomiting sensation, fainting and stomach nausea when we travel in roller coaster because of the curved or twisted tracks. Those who travel in roller coaster, we can give this example. But for those who doesn't travel in the roller coaster, we can give examples like traveling in hill stations. In the hill stations, the roads are very curved, whereas we get the same sensation as in roller coaster. The same formula appears here also, that is AC is equal to B square by R. Here AC refers to sentimental acceleration, B is equal to velocity and R is equal to radius of a circle. This mechanism is known to the mechanics since 1865 and that's what I conclude my speech. Thank you.
Good afternoon to everyone. Welcome to Max Symposium. Myself Ramakritika. Myself Tiyashri. Myself Priyanka. Myself Ishika. Myself Tanusha. Together we are going to explain you the concept of mathematics in architecture. First, what is architecture? Architecture is the study of art and technique of designing and building. Why is maths used in architecture? Maths is used in architecture to give the buildings and monuments perfect shape, symmetry and alignment for safety and aesthetic appeal. Now let us see the 5 concepts of mathematics used in architecture. The 5 mathematical concepts used in architecture are symmetry, trigonometry, geometry, algebra and golden ratio. These are the applications of these 5 maths topics, starting with Sun Konark Temple at first. Firstly, let us start with Sun Konark Temple. It is located in Odisha, India. It is designed as a chariot containing 24 wheels in it. The speciality of this temple is each wheel shows the exact time. It acts as a natural sundial. It is designed using symmetry for maintaining balance and harmony. The golden ratio of this temple is 1.58. Now let us see about Qutub Minar.
The Qutub Minar in Delhi is also an example of mathematics in architecture. Some of the maths concepts used here are geometry. The Qutub Minar's tapering shape is an example of geometry with the diameter of 2.75 meter at the top to the 14.32 meter at the base. The surface is mainly decorated with inscriptions and pattern. Here we go with the next example.
The next example is the Pyramids of Giza located in Egypt. As you know, the Pyramids of Giza is the great wonders of the world, but do you know it is also a math wonder? It is a mathematical marvel that ancient Egyptians had advanced knowledge about geometry and volume.
Its slanting shape, slope, and alignment are based on math principles such as shape, volume, alignment, and some other.
The last application is the marble run, which we'll be seeing now. Marble run. Marble run is application of architectural engineering, and it is also it's also related to maths by the probability. While we roll the marble, it goes and hit the end point without flaws. The probability is where it stops or reach the end without no flaws. Its aim is to reach the point without no flaws. It was made by a German glass blower in 1856. 2.5 degrees is the best angle to rotate a marble run. Thank you.